Hello everyone, Miss Meek here, and today we're going to talk about the triangle inequality theorem. Now this sounds super complicated, and it really isn't. The triangle inequality theorem is how you can tell if three sides will actually make a triangle, because you would think any three sides would make a triangle, and actually that's not true. There are some rules about what side lengths you can have in order to make a triangle, and so we're going to go over the theorem here. First of all, we're going to color coordinate some stuff here to make this a little bit easier. So remember how we talked about how that if I have a side on a triangle, we can mark it like this. So this is side AB, okay? This would be side BC because it's the side length between the letters B and C. And then this down here would be side AC because it's in between the sides between side A and C. So it's the side length between those two letters. So that's going to be important because we're going to be using these to figure out if we can make a triangle or not. What the theorem says is that if I take side AB and I add it to side BC, so I add those two side lengths together, those two side lengths have to be greater than the third side, which is AC. Now, you have three sides on a triangle, so that means that you have to check some of the other combinations. So not only does AB and BC have to be greater than that third side, but I also have to add side AB to my green side there, side AC, and those two sides together have to be bigger than my blue side BC. And then there's one more side that I haven't added together that I have to check. I have to add side BC with side AC, and those two sides together have to be greater than my red side, which is side AB. Now, if the answer to all of these is yes, these all work, then you have a triangle, okay? If at any point one of these is not true, okay, so for example, say these two work and this one doesn't, then you do not have a triangle, okay? It takes all three of them to work in order to form an actual triangle. Now, this looks super complicated because this is the bare bones of the theorem. So let's go ahead and let's apply it to some actual side lengths and find out, do we have triangles or not, okay? So I'm going to give these side lengths colors just like we did on our a theorem example there, okay? So the first step is I'm going to add red and blue. And red and blue together have to be greater than green. So that's my first combination, okay? 6 plus 7 is 13. Is 13 greater than 4? Yes. So far, so good, okay? Next step, we add red and green together, those two sides, and they have to be bigger than blue. So 6 plus 4 is 10. Is 10 greater than 7? Yes. Awesome. Our last check is to add blue and green because I haven't added those two together yet. And those two have to be bigger than red. Is 7 plus 4, that's 11. Is 11 greater than 6? Yes. And I have check marks on every single one of these. And so, yes, these side lengths would make a triangle. This is a triangle. So these side lengths actually would fit together to make a triangle. So notice how we added red and blue, and it had to be bigger than green. Then I added red and green, it had to be bigger than blue. And then I added my blue and my green together, and it had to be bigger than red. It's checking every combination to make sure that these sides are actually going to work and form a triangle. Because if they didn't form a triangle, so remember, this is a triangle. It's a polygon, so that means that it's a closed figure. If these didn't form a triangle, you would end up with like something like this, where it doesn't actually connect. And so that's why we have to check these side lengths to make sure they work. Let's go ahead and do another one. So again, I'm going to give colors. I think the colors help. They help me definitely make sure I add all the things together that I'm supposed to add together. All right, so step 1, red plus blue. So I'm going to add those two side lengths together, and they have to be bigger than green. So 11 plus 3 is 14. Is 14 greater than 5? Yes. So far, so good. Now we're going to add red and green. I'm going to add those side links together, and they have to be greater than blue. Okay. 11 plus 5 is 16. Is 16 greater than 3? Yes. Okay. Last step is blue and green. So 3 plus green, that's 5. And those have to be bigger than red, which is 11. What's 3 plus 5? That's 8. Is 8 greater than 11? No, it is not. So because I have this one no, it messes up the entire thing. This would not be a triangle, not a triangle. It would not form a triangle. It would form, honestly, it would actually form something kind of like that. Like that's what it would look like, because this would be your 11, this is your 5, and then that 3 is just not long enough to connect it all the way up. And so that does not form a triangle. All right, so this is how you test if side links will make a triangle or not. It's kind of weird. You would think that any side links would make a triangle, but actually it's not true. They have to be certain. There's a certain rule about them. They have to be, the two side links have to be greater than that third side, and you have to check all of the sides, because if one of them doesn't work, it does not form a triangle. All right, I hope that this cleared up any confusion you had about whether or not side links make a triangle or not. I'll talk to you later. Bye.